Look, pizza restaurant. Oh, this is a tricky decision. What do you think? Should we go for a 12-inch pizza for $5.99 or two 8-inch pizzas for the same money?
I reckon two 8-inch pizzas are more.
I don't think so. I think we're going to get more on the 12-inch pizza.
Well, looks like we're going to have to do some maths for real to find out who's right.
Kate, have you got any money? Today's programme is about calculating area. If we calculate the area of each pizza, we can work out the total area of the two 8-inch pizzas compared with the total area of the one 12-inch.
Assuming the pizzas are perfectly round, we need to start by working out the area of a circle. And the formula to use is A equals pi r squared.
Where A stands for the area, r is the radius of the circle, and pi is a Greek letter which stands for a number, which is approximately 3.14. But more of that later on.
You need to remember that formula, and to help you do that, watch this.
Here I have my pizza, which I've divided into 8 equal slices. But look what happens if we rearrange it. It's a little bit bumpy around the edges, but it's starting to look like a rectangle. Just imagine what it would look like if I cut my circle into even smaller slices.
Which is exactly what's happening here. This circle has been divided into 32 equal pieces. Rearrange them side by side and it looks much less bumpy than the pizza, which was cut into 8 pieces. The more slices you split the circle into, the closer it gets to becoming a rectangle. Now we have a shape whose area we can easily calculate. As you know, the area of a rectangle is length multiplied by width.
First, the width of the rectangle. These slices here come from the original circle, so the distance here is the same as the circle's radius. What about the length? Well, these pieces form part of the original circle's circumference. So half the circumference is the top length of the rectangle, the other half is the bottom length. You should know the circumference of a circle is 2 pi r. So the length is half of that, which is just pi r.
That makes the length pi r and the width r. So the area of the rectangle is pi r multiplied by r, which is pi r squared. So the area of the circle we started with must be pi r squared as well.
Finally, we can work out whether Katie's two 8-inch pizzas are bigger than my 12-inch pizza.
To find the area of one of these pizzas, I need to know the radius. Now, it's an 8-inch pizza, which means the diameter is 8 inches. The radius is half of that, so that's 4 inches. 4 squared is 16, multiplied by pi is 50.26548246. Now, there's no point rounding this number yet because I've still got more calculating to do. I need to multiply it by 2 because there are 2 pizzas. And that gives a total area of 101 square inches. That's rounded to the nearest square inch. Beat that, Mr. Stocks.
OK, Miss Natman, I will. The diameter of my big boy pizza is 12, so the radius is 6. 6 squared is 36. And 36 multiplied by pi equals 113.097, which, the nearest square inch, is 113. So, I think you'll find that's 12 square inches more pizza for the same money. Listen, Katie, don't worry about it. I knew my pizza would never be topped. Topped. Did you get it? This is one of Europe's leading drinks can manufacturers. They make over 6 million cans a day. And whichever way you calculate it, that's a shed load of cans. And believe it or not, this lot is just a small part of that shed load. Each pallet, like this one, has 8,500 cans on it. And one of these little beauties comes off the production line every 2 minutes. The cans start their lives as a huge sheet of metal. The first step in the can-making process is to stamp out a series of circles like this, which are then immediately shaped into a shallow cup like this. Next, the cup is drawn out, gradually becoming taller and thinner. Then it's washed and printed, before going through another machine that does this bit. That's why it's called a necker. Aluminium is expensive, so the factory needs to cut as many circles as possible from it. There are 7 cutters in a row, then another row offset to fit together as closely as possible. What's left is a web of waste aluminium. This is chopped up and crushed into bales ready for recycling. But if it wasn't recycled, how much aluminium would the factory waste? To work it out, I need to calculate the area of the web. I'm going to start by working out the area of the metal left behind in this highlighted purple row. But it's easier to see what a row looks like on my diagram. A row consists of 7 full circles and 14 half circles. And the dimensions of the row are 173 centimetres wide and 14 centimetres long. And 14 centimetres is also the diameter of each circle. Now, to work out the area of waste, we first need to work out the area of the rectangle before the circles were stamped out. And that's 173 centimetres multiplied by 14, which equals 2,422 square centimetres. And the next step is to work out the area of the circles that have been stamped out of the row. The area of each circle is pi r squared. The diameter is 14. The radius is half of that, which is 7. 7 squared is 49. Multiplied by pi is 153.93804. But that's the area of one circle, and trust me, there are 14 whole circles in the row, so I need to multiply that by 14, which equals 2,155.13256 centimetres squared. Now, to work out the area of waste, I need to subtract the area of the circles from the area of the rectangle, and that equals 267 to the nearest whole centimetre squared. Ooh. That's the waste produced in one row. In fact, 425,000 rows are stamped out daily. If it wasn't recycled, how much aluminium would the factory waste in a single day? Can you work it out? Do you get it? Can you work it out? Never mind. It's that time again when both Katie and I tackle the same maths question, but only one answer will be right.
The other will contain a deliberate mistake that you've got to spot. So watch carefully to decide if you're going to tick it or trash it.
The diagram shows a circular garden pond. The diameter of the pond is 3 metres. It's surrounded by a path 0.5 metres wide. Now calculate the area of the path to 2 significant figures using 3.14 as the value of pi. Pens on your marks. Set. Go.
Go! The diagram shows a circular garden pond. The diameter of the pond is 3 metres. It is surrounded by a path 0.5 metres wide. Calculate the area of the path to 2 significant figures using 3.14 as the value of pi.
I started by finding the area of the pond using A equals pi r squared. The radius is 3 metres. 3 squared multiplied by 3.14 is 28.26 metres squared. To work out the area of the path and the pond, I use the same formula, but a path of width 0.5 metres on either side means the total radius is now 4 metres. And 4 squared multiplied by 3.14 is 50.24 metres squared. Now, to find the area of the path, I subtracted the area of the pond from this figure, and I got 22 metres squared to 2 significant figures.
I also started by finding the area of the pond using A equals pi r squared. The diameter of the pond is 3 metres, so the radius is 1.5 metres. 1.5 squared multiplied by 3.14 is 7.065 metres squared. To work out the area of the path and the pond, I first worked out the new radius. That's 1.5 plus 0.5, that's the width of the path, so the new radius is 2 metres. 2 squared multiplied by 3.14 is 12.56. To find the area of the path, I subtracted the area of the pond from this figure. And the answer is 5.5 metres squared to two significant figures.
So, who's working slick enough to get the tick, and who's going to crash out with the trash? Who made the deliberate mistake?
Is Jamie right with an answer of 22 metres squared?
Or is Katie right with an answer of 5.5 metres squared? OK, the game's up. It was my answer that's wrong. I used the right formula to find the area of a circle, but my mistake was to square the diameter instead of squaring the radius.
If the question gives you the diameter of a circle, you need to half it to get the radius. The other thing to remember is not to round your answers too early. Only round your answer right at the end of the calculation. Another maths textbook favourite is the shape of a running track.
And that's why we're here at the Don Valley Stadium in Sheffield to check it out for size.
It has two parallel straights.
And two semicircular bends.
For this to be an international athletics track, its dimensions have to follow very strict rules.
Which means every measurement has to be just right. Each lane has to be between 1.22 and 1.25 metres wide.
The white dividing lines have to be 5 centimetres wide.
The length of one lap around the inside of the track has to be 400 metres.
What you end up with is a shape like this. Mathematically, it's the area inside the track that we're interested in. To work out how to calculate its area, there are two challenges. One is to be able to spot the simple shapes it's made up of.
The other is what dimensions you need to know to be able to calculate the area of the whole thing.
While you're thinking about that, we've got a bit more measuring to be getting on with.
Come on, Katie, no time to chat. The truth is, you just need two measurements to work out the area of the whole space inside the track. Number one, the length of the straight, and number two, the distance between the two parallel straights.
That's because the area within the track is in fact a rectangle with a semicircle stuck on either end. The length of the straight, which is 85 metres, is the same as the length of the rectangle. The distance between the two straights, which is 72 metres, is the width of the rectangle, and that's also the diameter of the end semicircles.
The total area is the area of the rectangle plus the area of the circle made by the two semicircles. The area of the rectangle is length multiplied by width, that's 85 multiplied by 72, which is 6,120 metres squared.
The area of the circle is pi r squared. R is the radius, that's half the diameter, which is 36. 36 squared multiplied by pi is 4,071.504079. Adding them together gives a total area of 10,192 metres squared to the nearest square metre.
Now we've worked that one out, what further measurement would you need to be able to calculate the area of the track that the athletes run in?